Thank you for joining this lesson. We're going to study linear programming. Number 24. Mr. Kamau, a dropper in Pendletown, is required to supply two types of shirts, type A and type B, to Pendle Secondary School. The total number of shirts must not be more than 400. He has to supply more of type A than type B shirts. However, the number of type A shirts must not be more than 300, and the number of type B shirts must not be less than 80. Let X be the number of type A shirts and Y be the number of type B shirts. Part A, write down in terms of X and Y all the linear inequalities representing the information above. So let's get to the information above now. Remember, type A shirts, we shall use X, and type B, we shall use Y. So we are told he's going to supply shirts, then the total number of shirts must not be more than 400. So when we take type A and we add type B, we must not be more. So it should either be 400 or less than that. 400 or less than that. This is the first inequality. The second one, we are told that he has to supply more of type A than of type B. Therefore, type A, which is X, must be more than type A. This is our second inequality. We are told further that, however, the number of type A must not be more than 300. So type A must not be more than 300. So it can either be 300 or something less than that. It can't be more than 300. So this becomes our third inequality. And also, type B must not be less than 80. So type B must not be less than 80. So it means it should be 80 or something greater, because it should not be less than 80. So these are the four inequalities now. The four inequalities representing the above information. Then we are told now in part B, on the grid provided, draw the inequalities and shade the unwanted regions. Draw the inequalities and shade the unwanted regions. Let me use a different grid here for perfection, because I know the one on the paper is not that excellent. So we're going to draw the inequalities now which have been stated. So these are the inequalities. So instead of inequalities, now when we get to the graphical work, we don't use the inequalities, we use what we call borderlines. So we change inequalities to borderlines, whereby we substitute the inequality signpost with equal signs, so that the inequalities change to borderlines now. So this is my Cartesian plane. I want to use some good scale to come up with a graph. So we're going to have Y here and X here. Remember, X is type A. Therefore, let me start with the second inequality, whereby we need X to be equal to Y. So X equals to Y. Okay, I'm seeing 400s, 300s. Therefore, you can allow me to use a scale of 50. To use a scale of 50 for every small square in the x-axis, and a scale of 100. A scale of 100 in the other axis. Therefore, we can use from 0, we can go to 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, and such. So that is the scale here. On the other axis, let me choose a better scale for the y-axis. For the y-axis, let me use not 50, like in the other, not 50. 0, 50. Okay, let me use the same. Let it be uniform. We can have 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, and such. Therefore, now we have the Cartesian planes now. So the first inequality, before we get to this one, the borderline for this one requires a table. The second inequality, x equals to y. X equals to y. Therefore, we use when x is 50, y is 50, x 100, y 100, x 150, y 150. So this is the borderline. And because we are told that x is simply greater than y and not equal to, we are going to use a dotted line for this case. Therefore, we use a dotted line and not a complete line. So we're going to use an incomplete line for this borderline. So for this borderline, it will be represented by an incomplete line. The borderline equals to y is equal to x. Then the second one, we're going to use x less than or equal to 300. X less than or equal to 300. So x at 300, we're going to have this borderline and it should be complete. So x should be less than 300. X should be less than 300. Therefore, being less than 300, it means this will be our unwanted side for that inequality. So x equals 300. So here we're using x equals 300. In this one, we use y equals to 80, and it should be complete. So y equals to 80 from 50, 60, 70, 80. So that is the point. It is also going to be a complete line. So because y equals to 80 and the inequality says that y has to be greater than 80, then it means this is the unwanted side. And it should be shaded like that. Then we're going to have another inequality here, which says that x plus y equals to 40. So we're going to use x plus y equals to 400 as the borderline. X and y values. When x is something like when x is 0, for instance, y has to be 400. And when y is 0, x becomes 400. So that is the line we want. So we use the intercepts, 400, 400 each. So at 400, this is where the line will cut the x-axis. And at 400, it is where the line will cut the y-axis. Therefore, now we draw a line connecting the 2 points. Yes, so that is the point. Therefore, a common region, this is y plus x equals to 400. This is the line. Therefore, we're going to have this region shaded. And this one also shaded because it is evident that the shared region is this one. This is the shared region amongst all the inequalities. That will be the shared region. Therefore, we have very many combinations here. Very many combinations. Therefore, now we're going to choose. We're going to have our region here. Then now we proceed with the question. And the question is telling us now. It's telling us that Mr. Kamau made profits of 600 per type A shirt and 400 per type B shirts. Then we are told to use the graph to determine the number of shirts of each type that should be made to maximize profit. So to maximize profit, we are told that for type A we have 600. This is type A, which is X, and 400 for type B, which is Y. So this one is called the objective function, and we're going to get what we call search line so that we may maximize. So for us to get the search line, we plot, if we have 600x, we interchange the coefficients such that in the Y axis we're going to plot 600, and in the X we plot 400. So we interchange. We have 400 getting to X and 600 getting to Y. Therefore we're going to plot XY 400 600. We interchange the coefficients. After interchanging the coefficients, we should know that now these coefficients can be simplified using a common factor like 10, whereby we will have 40 60. Therefore we're going to plot 40 60 on the axis, 40 60 on the axis. So we make these intercepts now, X intercept to be 40, Y intercept to be 60 for the search line. So 40 and 60, 40 and 60. So 40, if this is 0 to 50, 40 is going to be here. Then the other one is supposed to be 60. So just above 50, 60 is here. Therefore, when we connect the two, we're going to get our search line. We're going to get our search line. So this is called the search line now. So what we do with the search line is that we take our set square and our ruler. The set square and the ruler. So this is my set square, this is my ruler. Then we arrange the set square such that one edge of the set square is in line with what we are calling the objective, not the objective function, but the search line. So this set square is in line with the search line. It's in line with the search line. Actually, to be the other way around, this way, such that one face of the set square is in line with the search line, that way. Then now I use my ruler. Let me get my straight ruler, so that using my ruler and the set square, which is already in line with the search line, I am supposed to slide the set square until I get to the last possible point within the region. Therefore, the last coordinate, when I slide the set square such that this edge is always parallel to the search line, will give me the maximum profit. Therefore, this is maximization now. I'm maximizing. So I'm now within the region. I continue moving within the region. Continue moving within the region. I'm still within the region. Still within. So the last coordinate within the region, is going to be this one. The last coordinate within the region. The last coordinate within the region is going to be this one. This is the last coordinate within the region, the last possible coordinate within the region. So I'm getting 300, 100 for the other type. So 300, 100. So the combination of shirts will be 300, 100. This is type B, this is type A, respectively. Therefore, now to calculate maximum profit now, we will say we have 6,000 times 300 plus 100 times 400 each. So we're going to get 18 4 zeros. This is going to be 40,000. Therefore, this is going to give us 58,000 as the maximum profit.